And with me is our astronomer, Rachel, for another Ask an Astronomer. And Rachel, we have got a packed show today because this is our only show for December. So we got a lot of news to get to. But first off, how's your holidays, pre-holidays been going?
It's been good. I spent most of it reading, which is really nice. Yeah,
Now is the time to do lots of reading. Anything
exactly.
good that you're reading?
Right now I'm reading Ender's Game, which I hadn't read before, and I was
Okay.
thinking of reading the book and then watching the movie, and
Okay. Yeah,
but we'll see how it goes.
I've done both of those things. The book is a
Yeah,
lot better than the movie, I can tell you that.
that's what I figured, and I was like, oh, maybe I should have flipped it, so then I wouldn't disappoint myself in watching the movie. But
Yeah, and welcome to all of you that are out there in the chat. Please let us know where you're watching from and who you're watching with, because for the next 30 minutes, Rachel and I are going to talk about a whole bunch of fun stuff that are happening, but we'll also get to all of your questions as well. So make sure to put those in the chat. And Rachel, we have got some breaking news today. The sun is doing some activity. Some strange stuff is happening on the sun. So we're going to start with what's happening on the sun. We're going to get to some international space missions. Japan, China are doing fun stuff out there in space. And then, of course, we're going to wrap up with Back Up at the Cosmos, a very special event that's happening on Solstice, December 21st, as well as some meteor showers. So, why don't you start us off with what is going on with the sun right now and how could it affect us?
sure. So our sun is going through a period of increased activity. And so what our sun is essentially just a huge ball of electrically charged hot gas. And that charged gas moves around, and that generates a really powerful magnetic field. And the sun's magnetic field goes through something called a solar cycle. And it happens once every, or the period of the solar cycle is 11 years long. And so what that means is I can play you a video that every 11 years or so, our sun's magnetic field completely flips. And you can see that here in the pink and green lines. You're going to start to see them start to turn and appear in different locations. And so that means that the sun's north and south poles, or the geomagnetic north and south poles, switch places. And then in another 11 years, they switch back, and it does this flipping back and forth, back and forth. And so this solar cycle affects activity on the surface of the sun, and especially in the form of sunspots. Now, sunspots are caused by the sun's magnetic fields, and as magnetic fields change, so does the amount of activity on the sun's surface. Now, because our sun changes so much, it can take months to declare things like a solar minimum or a solar maximum. They need months of observation. So scientists use something called, or they use sunspots or dark splotches on the surface of the sun to track where the sun is in its solar cycle. And our solar minimum was declared in December of 2019 by two groups, by NASA and by NOAA. And it's predicted that our solar activity is going to start to ramp up now that we've passed the minimum. We're heading towards a solar maximum, and that'll happen in around July of 2025. Now, with this upswing of solar activity, we're going to have a lot of changes in our space weather, and that'll impact our lives and technology here on Earth, as well as the astronauts that are currently in space. If you take a look on the right here, we have what's called a coronal mass ejection. So that's when the sun's magnetic fields release a huge amount of energy. And you can think of it kind of like if you twisted a rubber band and then all of a sudden let that rubber band switch back to a relaxed position. That would be like the magnetic field releasing all that energy. And in this case, it's a lot of mass and matter being released by the sun. And so when we have Earth directed solar storms, on the right here, we see that it's kind of a halo where this mass is being ejected. So we do have some of it coming towards us here on Earth. We can have damaged power grids and also disrupted satellite communications. But there's also some good news with coronal mass ejections and solar activity, and that is that coronal mass ejections, or CMEs, can jostle the Earth's magnetic fields, and that creates currents that can drive particles towards the Earth's poles. And when these react with things in our atmosphere, so things like oxygen or nitrogen, they help create the northern and southern lights. All right, so this is particularly exciting. And this is Hayabusa 2 with the asteroid sample return. And this was a mission launched by the Japanese Space Agency to return samples of asteroid Ryugu to Earth earlier this month. Although modern spacecraft instruments are incredibly useful for initial measurements off of Earth, certain experiments can only be done on Earth. So things like high precision instruments that are too large and require more power than solar energy can give. Now, the spacecraft launched in 2014 to survey this asteroid and collect a surface sample. And so scientists can now analyze that surface sample and pinpoint when in the history of our solar system the asteroid's materials formed. So why is this important? Well, our solar system is filled with leftover planet building materials like comets and asteroids. And from the disk of dust and gas that formed the planets 4.5 billion years ago, we can almost use an asteroid sample as a time capsule to peek back 4.5 billion years ago to that point of formation in our solar system's history. And now, because on Earth, we have things like weather, we have geological activity, things that erode the surface of the Earth. We don't have fresh samples from that period, but asteroids like this one remained relatively untouched since the formation, since 4.5 billion years ago. So that's why getting the sample is essentially like a time capsule and very important for us to learn more about the history of our solar system.
Nice. And this Hayabusa 2, they returned the sample and they arrived in Australia just the other day, didn't they?
They did. And I have pictures of that. And it's really cool to see the researchers very excited over finding this capsule. But I thought I'd tell you how the probe got the sample in the first place. And it uses a meter-long horn that extends from the bottom of the spacecraft. And when that horn touched the surface, it fired a bullet-like projectile, and that kicked the surface material up. And you can see that happening here on the left. And then later, the spacecraft transferred that material or sample to a bin and to the Earth return capsule, where the spacecraft has dropped it off in Australia for recovery. And I thought I'd also include on the right-hand side here an actual image or movie shot by a rover that was deployed by the spacecraft. And so this is what it looks like on the surface of that asteroid.
So is this rover still on the asteroid?
Oh, that's a good question. I would imagine so. They deployed 2 rovers, so maybe they'll keep each other company on the asteroid.
And it landed back. Yeah, so it landed back down. Oh, you've got some more pictures here. Great.
Yeah. So this sampling event happened in July of 2019. And on the left-hand side here, we see a sped up version, 10 times the normal speed of that touchdown. And actually, one of the samples that the spacecraft collected actually came from an artificial crater that was made by the spacecraft itself. It fired a copper plate into the surface, and that was meant to expose fresh material underneath.
It looks very similar to the OSIRIS-REx mission. Were they using the same method?
Very similar, yeah. So because they wanted the freshest sample possible, they both were trying to disrupt and kick up, I guess, dust that was on the asteroid to try to collect it, which is a lot simpler than having a shovel and going and digging right. into the surface. But what I'm showing you here is the re-entry capsule carrying the sample back to Earth. And it looks kind of like a fireball, which is a particularly bright meteor, as it streaks past through the atmosphere and burns up. And because the spacecraft is still healthy, the Japanese Space Agency decided to extend the mission to study 2 more asteroids. So the spacecraft will fly past the first additional asteroid in 2026, and then it'll land on the second one in 2031. So we have something to look forward to.
Awesome.
So here are the images of the recovery in Australia, and there on the right-hand side is the sample itself.
Amazing. And we do have a potential interview lined up. So next week, check the YouTube page. I'm hoping to talk to somebody from the Japanese Space Agency. And Rachel, if you're available, we should definitely do that. They're on their own schedule. So it may be at some random time, but make sure to check out the YouTube page because we may get word from the Japanese Space Agency. They want to bring it back to Japan first, and then they can analyze. And they said they were going to wait until they got back to Japan before they talk to us, because then they'll know sort of like how much they have and be able to analyze it a bit. And they also seem very tired when I talk to them as well.
Well, that would be really cool to ask some questions about, the science behind the sample return and what they're going to do to the sample. But speaking of international missions, we also have a Chinese mission that is going to the moon, or went to the moon, rather. So the dark splotches that you see on the moon are remnants from a really traumatic time in the moon's history. And so this is the time where asteroids and comets were slamming into the early Earth and also the moon, and that actually likely brought water that helped kickstart the beginnings of life to the Earth. But what happened exactly and when it happened is still up for debate. So to piece together the moon's history, researchers are studying lunar samples from different regions of the moon to try to determine the age and the composition of the material, much like what we saw for Hayabusa's 2 asteroid collection. And so now that the spacecraft has a sample, once they return the samples to the Earth, that will be the first moon samples to be returned since the Soviet Union's Luna 24 mission in 1976. And they should also be the youngest samples ever returned to Earth. They would be just 1.2 billion years old when multicellular life on Earth may have already started to evolve.
Awesome. I love that there's so much international activity that are happening in space right now. It's not just NASA and the Americans. We got Japan and China, and of course, always involving the partners as well. So even Australia has a space program, if you can believe it.
So I thought I'd show you where the spacecraft landed in relation to the Apollo missions, as well as these missions from the Soviet Union. It landed in something called the Ocean of Storms, or Oceanus Procellarum. I had to look that up because I didn't know how to pronounce it. But so in this area, in Ocean of Storms, this is where you have the really young samples. So in the other areas to the right, where Apollo and Luna are, they return samples that were around 3.1 to 4.4 billion years old. So this is much, much younger than the samples returned by those 2 missions. So what does the mission look like and where are we at? So the spacecraft has 4 pieces to it. It has a service module, a lander, an ascent vehicle, and an Earth return module. And so the first step is to launch the rocket into space, and then it achieves moon orbit. So it starts to orbit around the moon. And once it gets a stable orbit, then we start to divide the spacecraft into 2 pieces. So we have the orbiter that sticks going around the moon, and then we also have the part that is going to descend and actually collect the sample itself. And then once it collects the sample, the ascender goes up back to the orbiter and they dock together. And the samples are transferred to the returner and bringing the samples back to Earth. So it's on its way back currently. So it hasn't touched down yet, but it should be quite soon that they return the samples. And so here is the sampling event.
And just as we're watching this, just as a note for everyone watching, we're going to get to all of your questions. So we're going to go through a few more of our news stories. So if you have any questions about solar storms or the Japanese mission to the asteroid or to the Chinese mission to the moon, make sure to put them in the chat and we'll get to all of them.
All right. And here is a view from the spacecraft on the moon itself. It's a panoramic view when it landed on the surface. So it's cool to see what the spacecraft itself was seeing when it touched down. But we also have a bunch of things happening that you can see here on Earth. You don't have to go to the moon itself. You can see all these things from Earth, and they are spectacular. And the first one that I wanted to talk about, you've probably heard it in the news, and that is the Christmas star, or the great conjunction between Jupiter and Saturn. And what's really cool is that on December 21st, so on the winter solstice, these two planets will almost look like they're touching in the sky. So they're not actually physically that close together. They're still very, very far apart in space. Their orbits are very far apart. But to us, from our point of view, they're going to look like they're really close together. And in fact, they're so close together that there are, if you held out a dime and looked at the edge on of the dime and looked at the width of it, and you held it at arm's length, that's how far apart they are or going to be on the sky. So they've been getting closer and closer since September, and December 21st is when they will be the closest together.
But of course, when you're talking about them close together, that's really just from our perspective, right? Because Saturn is still much further away from us than Jupiter is, right?
Exactly. I think that the results would be catastrophic if Saturn was suddenly right beside Jupiter, the two largest planets in our solar system. But what's cool about this is that you'll be able to see Jupiter and Saturn, but also all of Jupiter's moons as well in the same vision of binoculars, basically, which is really cool because that doesn't happen very often.
And while we're here, Rachel, might as well let people know what the winter solstice means. Of course, we say the solstice, and of course, that is a very significant date for our journey around the sun. What exactly is the solstice, and what's going to be happening to our Earth?
So the solstice is really important when explaining seasons. And we have that common misconception that the seasons happen because the Earth is a little bit closer to the sun in its orbit and a little bit further away. And while that is true that we do have that at certain points in the orbit, we have something called perihelion, which I think Michael will talk a little bit about later, and aphelion. And those are the points where it's closer and further away. But that's actually not what causes our seasons. It's actually the tilt of the Earth that causes our seasons, that it's tilted a little bit towards the sun. And the effect of that is that you have a greater surface area that is being heated by the sun's light, and you have opposite seasons on the other side of the equator. So that's why you see Hawaiians celebrating Christmas in July.
Awesome. And we have one more up in the sky news, I believe.
We do, yes. Oh, sorry, I just wanted to say why they happen, and that has to do with the formation of our solar system. When our solar system formed, it was a big cloud of gas and dust, and it had some spin. And because it has some spin, it started to flatten out into a disk, just like you see here. Now, because of this, from our perspective on Earth, sometimes it'll look like the orbits line up just right, just like it will on December 21st, for these planets to look very close together on our nighttime sky. And the reason why these are so rare, the great conjunctions are so rare in particular, is because these gas giants are much further away than the other planets that you can see with your naked eye. And that means that they move more slowly across our sky. So it takes Earth 365 days to complete one orbit. It takes Jupiter 12 years, and it takes Saturn 30 years to do that same once around the sun. And the last piece of news that I have are meteor showers in December. And you'll notice that the Ursa meteors are also happening on December 21st. So December 21st is the day for astronomy, and 2020 off with a bang. But with the Geminid meteors, they are happening or peaking in mid-December. And what's interesting about the Geminid meteors is that the source of the meteors aren't from a comet. Normally we associate meteor showers with a comet, but the source of this one is actually from an asteroid. So that's particularly interesting. And what's more is that this is a very prolific meteor shower, meaning that you can see a lot of meteors provided that the weather is nice and it holds up. And just as a reminder for meteor shower techniques or viewing techniques is to make sure you dress warmly because it is December. Try to go somewhere where there's little light pollution, so a dark sky location, and let your eyes adjust for at least 20 to 30 minutes to the darkness. and have patience.
Absolutely. And once you do, there'll be lots of rewards, lots to check out up there in the nighttime sky, and lots of questions coming in too, Rachel. So we're going to see if we can get through as many as we can. First off, so let's go back to your first story, which was about the solar storms. Do the clouds have any protection for us here on Earth from some of that solar energy that's coming off the sun?
It's not so much the clouds, although you do have the right idea that we do have some protection from solar radiation, and that comes in the form of our atmosphere. Clouds are really just kind of ice crystals or water crystals that are suspended in the air, so they don't have very much defense against radiation. But our atmosphere does, and our atmosphere filters out some of the harmful radiation, like UV radiation. And this is also the reason why we want to send certain space observatories into space rather than having Earth-based observatories, because some of that radiation in the wavelengths or regime of light that we're interested in don't actually make it to the Earth's surface. So that's why we have to send satellites into space.
Right. So even if we can't see the aurora borealis, they may still have an effect on us. I know that BC Hydro is sort of keeping an eye on some of their generators, and occasionally, if they do hit those power grids, like there was a big power outage, I believe, in Quebec a few years ago, and it really caused some damage. So even if it is cloudy, it could still affect us. Is that what you're saying, Rachel?
Exactly. Yeah.
Let's move on because we've got a ton more questions here. One interesting one. So if we go to the moon and talk about sampling of the moon. Now, of course, in the formation of the moon, Earth and the moon sort of like were one, and we sort of discovered that through sampling of the moons. So the question is, how much of today's moon is composed of that initial planet, and is there a way that we're able to measure that?
Oh, that's a great question. And I think it has to do with that initial formation. So, like you said, Earth and Moon were one. And really, it was like the moon was part of the Earth. But then a Mars sized object called Theia smashed into the Earth and knocked off the pieces that formed the moon. So, most of the moon in that way would be from the Earth. But I imagine that because a collision requires more than one object, material from Theia would have made it in there as well. Because during the formation of the moon, we had that large chunk knocked off, but then we also had a little bit smaller pieces in orbit around the Earth, and those smaller pieces ended up assimilating or accumulating into what is now the moon. And now, in terms of how do we measure how much or what percentage of the moon is what, I think that is a question that will be answered from when the sample returns.
Right. Because as you say, we haven't had samples since the 1970s. So this is great. We have so much international effort to go and get some more of these samples, including one original sample that we have in our gallery space, in our cosmic courtyard. Unfortunately, most of the things that you can touch in our gallery space, we can't right now due to restrictions. But we are having some events that are coming up, so you can come into our gallery space and have a look at that moon rock, including actually a piece of meteorite as well, which brings us to another question, which relates to the story about the Japanese space agency going to the asteroid. One big reason that we do study asteroids is to protect us. So do we know of any asteroids that are coming close to Earth that might impact us?
So I had this question pop up when we were talking about Comet Neowise, because Comet Neowise is an interstellar visitor coming into our solar system and then leaving. And the way that we tackle near-Earth objects or near-Earth asteroids is in a similar manner to what we did for Comet Neowise. And that was we calculated the orbits and trajectories based on their current velocity, the direction that they're going in, how close they are to our Earth. And we actually calculated the orbits for Comet Neowise, I think, for the next few thousand years. So we're pretty sure that it's not going to impact us. But the same thing happens with near-Earth asteroids. But, once in a while, we do have some that slip past our radar, but hopefully they are small enough that they'll burn up in our atmosphere.
Absolutely. And of course, we see that remnants, the small remnants, when we have the meteor shower, right? The meteor shower that we're seeing right now was once a remnant of a past comet.
Exactly. Yeah. Or an asteroid for the Geminids. Yeah.
Do we know in particular which one it is that is the Geminids?
It's the Geminids. Yeah. So it's nice to have two kinds of meteor showers in December. We have the Geminids, which is an asteroid as a source, and then the Ursus, which is a comet.
Awesome. Let's get to some more general questions for you, Rachel. And this comes from one of the classes, I believe, from Cheryl. On the history of space exploration, do you know if there's ever been an astronaut with a physical disability? So one thing that we see, is without gravity, it's a lot easier to move, and you're not having to rely on some of those things. But do we know of any astronauts that have had a physical disability?
Interesting. I don't know personally of any. I don't know, Michael, if you have. But that's an interesting question because if you did have mobility issues, it would be a lot easier to navigate through something like the ISS. And I wonder if that would have an impact on maybe injuries relating to the spinal column because they have spinal column elongation. So it's kind of the similar idea to when, I don't know, maybe your friends tell you that when you lie in bed, your spine elongates a little bit and you get a little bit taller, and then you stand upright, go about your day, and then gravity compresses it a little bit. The same thing happens on the ISS where the reduced gravity allows that spinal column to expand a little bit. So I wonder if that would help or take away from people with disabilities.
Yeah, I don't think that there has been a NASA astronaut or one from the other space agencies that have gone up. But you can look up a video of Stephen Hawking, who suffered from a disease where he wasn't able to walk, and he went up on a plane where the astronauts do train, called the Vomit Comet, that simulates zero gravity, and you can see him floating around and having a really great time experiencing weightlessness. It's a really cool video to watch.
I wonder if Stephen Hawking vomited on the Vomit Comet.
They probably didn't tell anyone because
Probably
that would
not.
ruin the image of such an amazing scientist. Here's another general question from Jennifer Mendoza. I'm wondering if a black hole and white hole are the same phenomena, but a black hole would be the entrance of the gravitational pull, and a white hole the exit where the matter ends up. Great question, Jennifer.
And you're actually hitting the nail right on the head. That is exactly what we think a white hole could be. But white holes are still theoretical objects. We haven't yet had any evidence to support their existence. And it's kind of hard to get because you'd have to go through a black hole and then be spit out in a white hole. And they are really kind of like yin and yang, where you have the black hole, which takes everything with gravitational pull and pulls everything inwards, and then you have a white hole which ejects everything out. So you can't ever throw something into a white hole and have it stay there. It'll always be shot right back out at you. And the way that we theorize that white holes existed actually is just by drawing something called a space-time diagram. So by extending the diagram, they said, hey, well, if we just drew the lines a little bit more, there should be another object that would be the white hole.
Great. And our last question, before we get to some announcements, comes from Randy. So, of course, we're studying lots of asteroids coming in, but that incident that happened over Chelyabinsk, we didn't know that one was coming. So why are sometimes these surprises that enter into our atmosphere?
So my best guess would be that their trajectory got altered in some sort of non-negligible way. Oh, my mouth is so dry. So that when our tracking software is looking for these objects, it wasn't able to catch up with that drastic change in trajectory. And also because there are a lot of near-Earth asteroids in space, so it's hard to keep track of every single one.
Absolutely, which is why we need to study them more. We need to have more telescope eyes out there in space. Unfortunately, the Arecibo Observatory, which we talked about in our last Ask an Astronomer with our friend Natalie Willette, the Arecibo Observatory did actually use some radar tracking to help. So we need to build some more of those telescopes to help track, to help protect our Earth. All right, we got a last few minutes, and I do want to share a couple things with you. First off, this is our final episode of the year. We've been doing these Ask Astronomers since spring. Rachel, it seems like it's not been that long. So I really want to thank everyone that has watched these series and supported us. We really appreciate it. And if you like, and I'm just going to share my screen, if you're looking for some Christmas ideas or some present ideas, we have just put up onto our webpage some information about how you can dedicate a star. We have these beautiful packages that you can send a loved one a star. And if you do get one of these packages, what you can do is that you can email us, and Rachel and I can tell you all about the star that has been dedicated to you. And perhaps on a night when we have our observatory open, you can bring your package to one of our interpreters and we can help you find that star up in the nighttime sky. And you should also check out our website because we are going to be opening for some special events over the Christmas holidays. So on December 29th and December 30th, you'll be able to have a chance to come in. We're going to have observatory tours. We're going to have short presentations, of course, all socially distant, all safe. Unfortunately, because of the regulations, we can't have the theaters open, but we will have lots of fun stuff for you to see. And also, if you are also looking to decorate your Christmas tree, check this out. We have brand new H.R. MacMillan Space Centre constellation ornaments that you can hang on your Christmas tree. I love these things. So lots of ideas that you can use to hang on your Christmas tree. And once again, thank you all so much for all your support this year. This is our last episode of Ask an Astronomer for 2020. We will see you back on the second Thursday of January. Take care, everyone.
Bye.